Hi, everyone. I'm here. Can you hear me okay? Someone just type in the chat. Yes. So I've got some data, and I thought I would just reprocess it. I processed it last night, and I'll show you what I came up with. Oh, good. Thank you. Yes, awesome. I'll show you what I have. Give me 1 second, and I'll pull it up in Gimp. So it's my data of my results of M58. I processed it once. I'm not super happy with it. I mean, actually, take that back. I'm actually kind of happy with it, but the background is a little bit, I don't know, uneven, especially when you compress it and try to like make it a size that YouTube likes. So I'm going to go ahead and try and reprocess it, and I put the data itself into Discord. So if you would like to join my Discord, if you haven't already, I have, give me 1 second. I'll see if I can move it over here. So I've got a channel with all my data in it that you can access. And if you'd like to download it, feel free to work on it. It's not perfect. I'll say this, that like the flats didn't calibrate all of the like the dust bunnies out. So there's there are some problems with it, but I think we can work around it, especially because it's a galaxy and the galaxy doesn't have any problems with any of the dust motes on the galaxy itself. So I've sort of processed it out, and I'll show you how I do that. And I'm sure that if you're watching, you may have a better idea of how to process it than I do. But what I've done is I have stacked it in serial using Cyrillic. So I have LRGB and LRGMB data. It was taken by Ritchie Creation telescope. So it's a 6-inch telescope at 1370 millimeters, I think. So it's like around f10-ish. And so it's fairly slow. But I got about 7 or 8 hours of usable data. I mean, it's okay. But I've always had problems with flats in broadband with my RC. And I think it has to do with a couple of things. One, I think that the focuser just isn't very good, and so it tilts a little bit, and so that can mess up the flats because it's not perfectly aligned. Also, there is a tube. So imagine the tube, the whole telescope tube, and the primary mirror sits up front. I mean, the secondary mirror sits up front. The primary mirror is in the back. And there is like a little column that goes in that's supposed to block out light that's coming from the sides. And it doesn't quite block it all out. And I 3D printed a part, and I put it in there to help with that. And it helps a little bit, but you can, if you look inside the RC, you can still see light coming from the sides where it shouldn't be. And so when I'm shooting in sort of broadband LRGB, the light can get in there, and it kind of creates these weird reflections, and so it can mess up the flats. But we can go ahead and get started with the data. I've got serial open. Let me go ahead and open up the L. I'll start with the L processing, and we'll see what we can do with that. And you'll see what I mean with that the flats didn't calibrate out all the dust. Probably just have to clean things. But also, let me go ahead and start a poll. Let's see. I'm just going to ask you if you're currently working on an astrophotography project, which I've been working on this project since March, and I finally got around to actually looking at the data and processing it. I just haven't had much time to do things like creating the videos, working on a full-time job. It gets a little bit overwhelming. So one of the reasons I like to do the stream is because, you know, it's nice and relaxing. I kind of get motivated to actually process some data and talk with some cool people. So let's see. All right, let's go and do an auto stretch of the L, and I'll show you the, yeah, you can see the dust motes here, just all over. They're just all over the place. But we can go ahead and do a background extraction. That's usually the first thing I like to do. And I feel like Serial, like the RBF function, it does a good job. I like to set the background extraction to 100, like 1 in terms of the smoothing, so the max smoothing. And then I can decrease it to see how things actually go. And I also add dither because I get these weird gradient lines if I don't. Oops. I'm just going to go ahead and pick some sample points across the image. And then hopefully we can get rid of these gradients. You can see I've got, I mean, I took these basically with very little moon out, but I just have gradients across the image from light pollution and things like that. So we've got 1 vote for no. But how is everybody doing tonight? Are you guys all doing okay? Okay, I'm going to go ahead and compute the background. And then, yeah. So I got rid of the gradients, but it brought out, you can definitely see all the dust motes. And with the RC, I don't know what it is. Like with narrowband, it's fine. With with broadband with my refractor, it's fine. I don't have these dust motes. It's always with RC. Yeah, the flats, they didn't take them out. So I'm not exactly sure what's happening. I mean, I did use dark flats, so maybe the dark flats are also not doing it, but it's just, I don't know. It just doesn't, it's the RC. It's always my RC I have trouble with in terms of, you know, broadband imaging. Like there's something about, I don't know, trying to learn how to process 15 hours of North American Nebula. Oh, cool. What equipment are you using? Yeah, and Cindy, I've just always had problems, and I think there are some YouTube videos on it about my specific, you know, the GSO 6-inch RC that people just have trouble calibrating the flats out. Could also be part of the problem is I've also read that like my camera, the ZW294mm Pro at Unity Gain can kind of give you big, weird like gain sometimes, and so the gain settings can mess things up too. Yeah, I think that looks good. I'm going to go ahead and apply it, and I might try and reprocess this again, like with new flats or something. But like the flats I took were around the same period that I was actually shooting the target. So I don't know if I don't think that'll help. Maybe it's the dark flats. Maybe I did add dark flats to it, and so maybe there's something. Yeah, yeah, that's what I'm going to do. Clone stamping on the star list. Yep, that's exactly what I'm going to do. Because it's the galaxy, and you can just do it. So I don't think we have to like stretch it too much. But let's see, is there anything else that I want to do? Not at this point. DYI 3D printed EQ tracking mount. Oh, wow. That's pretty cool. Stock M4 thirds mirrorless camera, bad kit, 158mm lens that will be replaced soon. That's really cool. I always like those DIY kits. They make me inspired. I really sort of want to do something like that someday. Or maybe like take a Dobsonian and put it on an equatorial platform or something and see what I can do with it. But I don't know. Like I'd make my own equatorial platform. That's kind of hard. Okay, so let's go and stretch it, start stretching. So I'm going to use a generalized hyperbolic stretch. I've got the logarithmic scale on. I'm going to turn that off for the first stretch and just zoom in to 100%. We'll see. See what we can do. Let's see. I can't seem to get the tracking good enough to do subs longer than 15 seconds, but I'm also limited by Burl 7 size. Yeah. Yeah, those two things. Those two things, I mean, they kind of work together, right? Like, where'd that histogram go? Let's do this again. And not lose track of the histogram. Okay, so yeah, so the Borel 7 kind of, I'm not going to say it helps, but it does limit your exposure time. So, and 15-second subs, like, you can still get a decent image out of that. So okay, set the symmetry point, take the local stretch intensity up, and then increase the stretch factor and see what we can bring out. So start to see the galaxy. Maybe we'll stop there and then bring the black point down a bit and change this back to 1. I'm just going to keep an eye on this clipping to make sure we're not clipping anything. And then I click apply. I'm going to go back to generalized hyperbolic transformation because I like it. That's good. Yeah. Okay, let's do this again. I'm not going to increase the local stretch intensity too much. I'm going to try and do this logarithmic scale this time. And what I want to do is, I mean, what I think from what I've heard about this transformation is I want to make this line, I don't know if you can see it, like this curve, kind of as straight as possible. Wow. Let's see. So Sammy would say, I feel lucky that I have 32 core server. I drop the data on and just let DSS chip away for a while. 5,000 stub secs. Yeah, that's pretty crazy. I would think you would need a lot of RAM too. Like a lot of RAM would help with that. Hi, James. Nothing but rain. Oh no, processing all data. Yeah, it's the same here. I've had rain past couple of weeks. Well, I don't know, maybe the past week. It's been clear, but the moon has been out, and I've got my setup kind of set up for galaxies, and I just didn't feel like doing it earlier than that. But I've been working on M51 from March until till May when I've had the chance. 64 gigabytes of RAM, 24 terabytes of storage. Yeah, I think you would need something like that. Do you throw away your data, Samuel? Like when you get it stacked, you just toss the data, or do you keep things like just in case? So I could see how you could reach that pretty quick, especially with a camera with a big sensor size. We've had quite a bit of rain the past few days. Hopefully it'll clear up soon. Okay, so I'm going to set my symmetry point. Let's see, somewhere around here. And then let's start stretching. And that's honestly, like, that's not too bad right there. Like, I don't think I have to go much more. Otherwise, I'm going to start stretching out this. It's going to start getting too noisy, like the background. And the fainter parts of the galaxy would get noisy. But like, I really like the core. I like these barred spiral galaxies. I think they're really cool. I keep all my raw subs just in case I learn new tricks down the track. Yeah. Yep. That's good. I do that too. I keep all my raw subs as well. Okay, so let's see. So I'm going to go ahead and apply that. Let's try one more, because maybe we can bring this up a little bit here. So we'll try a symmetry point here, but I feel like I'm stretching it a little bit too much. I tend to do that. I also figure if I need to image an object again, it's still in the sky waiting for me. Yeah. One thing too, I think, is you can restack things, right? So if you still have your old images, you can just restack it with your new images as long as you have the same, using the same camera and things like that. And I think generally restacking like that is better than like stacking stacked, just because of the way the math is. But I haven't really double checked that, so don't quote me on that. But yeah, okay. Let's see if we can stretch this a little bit more. We'll see. I think I'm okay with this. You click apply and close. And then I'm gonna go ahead and run StarNet on this image, and I'm gonna go ahead and do star processing, StarNet star renewal, and then I've already stretched it, so I don't have to do pre-stretch linear image. I don't really want to recompose the stars on completion because I'm going to be going into Gimp and like trying to get rid of these dust spots. Yeah, so we're just going to go execute that. And it should take 30 seconds or so. Hey, the Duke Dennis clips, cool. You are so good at script. I don't know about that. I don't know if I'm good. I'm just stubborn. Stubborn. So I'm stubborn. So I get I get an idea in my head and I try it until it works. So yeah. Yeah, you lied. Thanks. Okay, so I think it's running about halfway done. And we'll see how things go. So. All right. Are you all ready for imaging nebulae again? I know like things are starting to pop up. All right. Okay, so we've got this. I'm gonna bring this into Gimp. So I'm gonna use again, just try and use only free software and we can see what we can do with it. So here's the first processed image I did. Let me go ahead and open it up and give me 1 second. Find the file. Yeah, that's true. Southern Hemisphere targets there are a lot more of them. I feel like a lot cooler targets. Okay. Okay, so here's the starless image. Open it up, and then here we go. Yeah, I see the comment. Yeah. Okay. So we've got this here, and we can clone it out pretty easily because the galaxies, again, only takes up a small part. Let's see. Cindy says, I had an imaging session on LBN 415 and Draco the other week, but haven't done anything since. I'm waiting for a friend to release a deconvolution neural network that can fix coma before I continue. Oh, that's pretty cool. Who's the friend? I know a couple of people who are working on things. I think that's pretty cool. That's really cool. I'm still working on AstroSharp. I'm still trying to figure out things. Hi, Gonzalo from Argentina. Cool. Installed Cyril. I think it'll be interesting to see how you can use it. Yeah, I was hopefully I don't lead you astray. So we've just removed the stars. I stretched the image using generalized hyperbolic stretch, and yeah, we're bringing it into Gimp so I can clone out all of these dust spots that are there because my RC telescope just doesn't like to calibrate out things. So, friend online I have, you wouldn't know him, but he's into this stuff. Does a whole bunch of other cool things with coding and whatnot. That's pretty cool. Yeah, I've got an idea for how to improve AstroSharp. I just haven't had time to like implement it. But the whole series I've been doing on convolution, so I've got two videos out on that. The first one is the first one is let's see, the one on circles and image frequencies, and the second one is on PSFs, and the third one will be related to noise because noise is very important in terms of deconvolution. If you have noise messes everything up, so it's very hard. And so I've got a plan as to what I'm going to do with the neural network to like, it's going to restructure the whole thing. And that will hopefully like make things better. And I kind of get it, like why Russell Croman has been saying that like his AI assisted deconvolution. I think I kind of understand what he's doing with it a little bit from what I've had with conversations with other people. But I think this one's going to be a little bit different. It's going to be based on a paper that I found that uses stuff. Joined your Discord, got a sign off for the night. Love following your stuff. Okay, cool, Samuel. Hope have a great night. Thanks for joining. So, okay, so let's go ahead and clone this. So let's go to tools and then clone. I feel that clone works better than heal for this because it keeps the like heal kind of like makes things less noisy sometimes. It gets rid of some of the noise that like, whereas clone, let's see, it like keeps it. I'm off to see you, James. Thanks. Whereas clone like keeps the noise in it. I don't know if that makes any sense. So it keeps the same sort of noise profile. But yeah. So it doesn't like look too weird later on. But also like heal the selection, but I don't know. Maybe I'll turn this down a little bit. But yeah. So AstroSharp, I've had some people ask me the question like, am I gonna change it? Am I going to try and improve it? The answer is yes. And I think I can make a better AI tool as well that, again, will use a convolutional neural network. And I think I've got some ideas about how to like actually make it to where you can have more fine detail control of how much denoising it actually does. I don't know if that makes any sense, but yeah. Like AstroSharp now, I think does pretty well. So, but it's not perfect. I can't fix the shape of the stars, for example. Okay, I'm just going over here, cloning this stuff out. And there's a lot of it. There's a lot. Yeah, I think I just need to clean my sensor. I don't think it's my sensor. I think it's my L filter. Don't have quite as many dust spots on my RGB filters. I take my L filter out a lot too because I've only got a 5-position filter wheel. And so if I want to do like narrow band imaging, then I take my L filter out, the RGB filter out, and I think my L filter just got some dust on it when I was doing that. Okay. Well, that looks better. I can add the stars in. Give me 1 second, and I'll find the file. So, okay, and I always like test, what looks better to add the stars back in, whether screen or addition. Here's a do it. Let's see, a denoising neural network I made myself using Python and code generated slowly from Chat GPT 3.5 and 4. That's pretty cool. I don't see the link. I don't know if I've got links disabled. Is it like, is it on GitHub? Oh, cool. Yeah, I can't see the link for some reason where I'm at. I can maybe check it. Maybe it's on YouTube. I can check it. Give me 1 second. I mean, I'm on YouTube, but like,
So we're wrapping up a detail right now.
let's see. Yeah, it must have been deleted by YouTube for some reason. I might have the settings where you can't post links. Yeah, or maybe it's the default setting. I don't think I've ever changed it. So it's probably just the default setting. Let me see. Let's see. Yeah, I don't know. YouTube probably removed it. Let's see, I think I have to, give me 1 second. Let's see if I can change the settings. Yeah, I don't know. I don't see anything right here that lets me change it. Yeah, that is strange. It's gone. Okay, so I'm going to go ahead and add the stars back in. Always look at addition and screen, because those are generally like the ones that seem to work the best. Let's go to addition as well. And I think like addition, the stars are a little bit less pronounced. I think I like screen more though, for whatever reason. Like it keeps the centroids of the stars brighter, which I kind of like sometimes. Let me just zoom in and check. Well, maybe addition's the way to go this time. I don't know, what do you all think? Addition or screen? It's hard to tell. I mean, if it's this hard to, like, if it's kind of hard to tell, I'll go with addition this time. Keep them a little bit softer. I don't know. Not quite as bright. Okay. All right. So we've got the L channel, right? Done. And now let's go ahead and do the RGB compositing. I'll go back to serial. Before I do that, I'm going to go ahead and change this image mode to RGB because I'll forget, and then I'll import the RGB image and it'll still be black and white. That's always one thing I like, I do. Okay. Okay, so let's go ahead and do, I've probably already got them here. So if I go to RGB compositing, I think I've already added here I've already added all of the images. And so we can look at the auto stretch. And it's very green, which I think is expected because I've got a lot of light pollution. So, I mean, it's not a ton, right? I've been in Bortle 10 zones before. I mean, there's no Bortle 10, but it felt like a Bortle 10. Okay, so let's go ahead and I'm going to go ahead and try and finalize the color balance right now and see what we can do. Use current selection and do a background neutralization. There we go. We've got the color kind of where we want it. And then I'll go ahead and then do a background extraction like I did before with the L image. And you can see, like, with my RGB filters, not nearly as many dust spots. So I think it's just the filter itself that needs to be cleaned. I should crop this. And then I'll have to align it in Gimp if I want to, but go and crop it, and then we'll do the background extraction. So how many, I'm going to head off for the night. Yep. I'm going to clear my, yep. Perfect. All right. Thanks. Thanks for joining. Okay. Let's see. So I'm going to go ahead and do the background extraction again. Set some points. The computer is being a little bit slow. Don't need too many points. Compute the background and we'll see what happens. Yeah, that's better. Good. Looks good to me. It's gotten rid of some of those gradients, I think. All right. So let's see. Now I'm going to stretch it again. But the first thing I want to do is an arc sign stretch because I kind of want to keep the star color. And I think doing this first just a little bit will help that out. So I'm going to increase the stretch factor just a tad until we start to see the stars in the image a little bit. I don't want to stretch it too much, but just enough to where we can start seeing the galaxy. I think this is, just zoom in a little bit, make sure we're not, yeah, that's a little bit probably too much. Don't need to, let's see, wish screen blend mode. The values of the pixels in the two layers are inverted, multiplied, and then inverted again. The result is the opposite of multiply. Oh, cool. I'm looking at blend modes on Wikipedia. Oh, cool. Nice, thank you. That's great. Yeah, I know screen like always makes things a little bit brighter. Like I've seen some people take like an image of a galaxy and then screen the galaxy again. And then they'll just mask off the rest of the image so the galaxy becomes brighter and it pops a little bit more. So yeah, I think that's probably about good for now. And then now we can do the generalized hyperbolic stretch transformation. So Gonzalo, have you been doing any astrophotography? If you don't mind me asking. Go ahead and put this back into linear mode. set a logarithmic, and we'll zoom into the histogram. And I'm going to set my symmetry point here. Increase the local stretch intensity and the stretch factor. It's way too much. Way too much, I feel like. Let's go back, bring it back down. Apply, I think we need a, oops. Let's do a linear stretch and bring the black point back down. Change it to 1. The computer's being a little bit buggy, I feel like. Yeah, it's, there we go. We'll go back to generalized hyperbolic transformation. Okay. So one of the things I might do, we've already sort of done a color calibration. I don't know if we want to do a photometric color calibration. Generally, I feel like photometric color calibration is really good when you're doing narrowband imaging, but like broadband imaging, kind of like to leave it as it is. But we can just test it and see what happens. There's nothing wrong with testing things. And you can quote me on that. Okay, let's see. So we'll try it. Photometric color calibration. Have M58 here. Put in my focal length and pixel size. And we'll try to see what happens. So if we look at the image after, so this is after, let's zoom in on this star maybe. We can see the before and after. I don't know, what do you all think? I started with astrophotography in the pandemic, but I like the hobby. I didn't take many photos and didn't post them. Yeah, I think astrophotography is like one of those things you can get really obsessed with. And then it can take up more and more of your time if you're not careful. But I like it too. I like it too. I've got a confession. You want to hear my confession is? I think I like visual observing more than astrophotography. Like, I know that sounds weird. I do like visual observing, but it just, visual observing takes more energy, I feel like. Like I set up, I mean, it's, once you get used to astrophotography and like setting up your scope and everything, like it just kind of flows. But like with visual observing, you have to actually be out there. And if it's like there's hot, like right now it's the summer, it's hot, there's mosquitoes, it can be a little bit irritating. But I really do like visual observing, and one day I hope to have like a huge Dobsonian mount and just be able to like go to some really dark site and look at M58 with my own eyes. But astrophotography is really cool too. Like, don't get me wrong, again, I enjoy both. Some people like to infer things that shouldn't be inferred, right? Like if I say I like visual observing more than astrophotography, they kind of think that it implies that I don't like astrophotography. But I do like astrophotography. So let's see, should we keep this color? Or should we? I guess we can keep the photometric color calibration. It's probably fine. Let's look at this blue star. The star is blue with the photometric color calibration. And before, it's a lighter shade of blue. I don't think it matters too much. It's not a huge difference. We'll be importing it and converging it, combining it with the luminance layer anyway. So I think it's fine. Okay, so maybe one thing that we could do is increase the saturation. I like the way you can increase saturation in Zero, where it just increases the saturation based on the brightness. So you can choose the level of the brightness that you want and then saturate that. So let's see here. So let's go ahead and, if I can find it, color saturation right here. So if we wanted to, we could turn this all the way up or all the way down and then, increase the color saturation of everything, right? Including the background. Or we can move this slider up and suddenly only the brightest things get saturated. And I kind of like that you can control that. So we've got to find a good spot where, I don't know if you can see this on YouTube. Hopefully you can see this outer layer kind of getting brighter or more saturated. If I turn this down, you can see like everything is saturated, turn it all the way up. Only this part is increase the saturation. So I'm going to go ahead and try and find the happy medium where we're not increasing the saturation of this too much, but we are increasing the saturation of things like the stars. All right, it's okay. It's an okay color. I mean, we can always fix the color in Gimp if we want to. And you'll see like once we change the blending mode in Gimp, then it should be a lot different. I'm going to save this. Let me go ahead and save it and then oops, lost it. Too many screens open. And then I'll go back into Gimp and we'll sort of merge things into Gimp. Find the file real quick. I'm going to open as layers. The file I just saved. And it's going to ask me like a couple questions, right? How do we want to replace the undefined pixels? So all of the hot pixels, what do we want to do with them? We'll just keep them as black. That works for me. And then image composing, this is really important. If you put none, it's going to split out the RG and B channels as separate layers, as black and white layers. We want to make sure that it's not none, it's whatever this is. And we'll just open it. Let's see. I also like to use the telescope visually, but I think you need a good aperture. Yeah, I agree with that. Like I think at minimum for a lot of targets, you need like an 8-inch aperture, which is like 253 millimeters or something. And bigger is better. Bigger is always better. I mean, for a lot of targets, you don't need that big of an aperture, like the Orion Nebula, like Andromeda, brighter targets. But for a lot of things, I think you really do need good dark skies and a big aperture, and you can get a lot out of it. Let's see, I recently had an 8-inch Edge HD, but I can't use it much because of the clouds. Oh man, yeah, that I feel you. The past couple of weeks has been cloudy every night, so I haven't been able to do anything. But I think I'm gonna go ahead and set up. I'm gonna set up the my refractor again and change to narrowband imaging anyway. So there's not. So hopefully, like no matter what the moon phase is, I can do some imaging, which right now I'm set up for like broadband imaging, which you know, it's best if the moon is not out. So it limits the number of nights that I have to actually do imaging. Plus my overall energy level kind of limits that. So sometimes I don't I don't necessarily have the energy to like set things up. Plus we adopted a dog like a month ago, and that has slowed me down a ton as well, because like the dog is 2 years old. She's a good dog, but like it's just a lot of work to do everything. So okay, let's see. So I've got the RGB image here. I want to first align the layers. It shouldn't need any rotation, but it should just need to be aligned. I'm going to go ahead and oops. Cyril and Gimp, they have like different ways to move to pan around the image, and it always like messes me up when I have to go from one to the other. Okay, so we've got the color image, we've got the luminance image, we can see the stars. So I'm just going to click M for move and click it up until I get it kind of where I want it, and then I'll use the arrow buttons to get it perfect. Yeah, I think it's good. Okay. And now we've got we should have the image aligned, I hope still. And what I want to do is change, of course, the blending mode from, generally I like LCH color. It tends to like do the best. So like, here we go, like it. I like the color of this. Yeah, I mean, it looks good. Let's compare it to the previous result. So if I look at the previous one, I have a darker background, but I kind of cheated to get a darker background. I kind of used the unstretched image and just put it behind it. Oh, congratulations. Yeah, they are good pets. Yeah, they're good pets. We like her. She's like a mix. We're not exactly sure what she is. She's got kind of like shepherd ears, so they're kind of like pointy ears, but kind of like a lab body. It looks like a black lab shepherd mix, something like that. And she's got a lot of energy. She starts out slow in the day, so like in the morning she's like doesn't have a lot of energy. She lays around a lot. Like once you get to 1 or 2, she's almost nonstop until like 9 or 10 at night. It's crazy. Oh yeah, thank you. The galaxy is looking better and better. Thank you. So this is the first iteration I did. I like this iteration. This is the second iteration, and I think what I did to darken up the background and to kind of clean it up was I just took I took the original stacked image and I just put it behind the stars and I masked it out. So I feel it's cheating. It's a little bit cheating. So I think with this one, plus it kind of makes for weird gradients because the original stacked image I didn't remove any gradients, so it kind of is weird if I stretch it. But yeah, I think, which one do you like better? Let's see. Let me do a poll of those that are still here. I'm going to end this poll. We're going to call this the second iteration and this one the first iteration. So far, like, which one do you like better? So I'm going to, so which iteration? a second. And if you all are, you know, following along, you guys can download the data, and all the software is free. Gimp is free. You know, Serial is free. AstroSharp is free. Everything is free. So like the data are free. Like I'm not like putting it behind any paywall or anything. People say the first. I kind of like the first better too. I feel like the color is better in the first one. This one's a little bit too yellow. So, I mean, one thing we could do is we go back to Serial. And maybe if we remove some of the green noise, it will like help. I don't know. It's made things. We can save it again. I don't know if it's worth it. This was generally my process. I think what I did, again, like with this one, is I took this background. Here, I think this is, yeah. So I took this, which was not stretched very much, and I put it behind her. I don't know, is it cheating? I don't know, you tell me. Tell me if it's cheating. And then I put it here as a new layer. Let me align it again. I've seen people do different things. Go ahead and align it. Put it at the bottom. Put it at the bottom, I said. My computer is not wanting to. Let's do this. And then I added a layer mask to this one. I made it full transparency so you can't see anything. And I just masked in the actual galaxy. I did an imaging session. Let's see. Okay, so oh, I'm missing. Let's see. I'm sorry, the comments kind of messed up. I thought I was looking at a new comment and I wasn't. Okay, and then I just mask it in like this. And I don't know if this is cheating. I think it might be cheating. And then I can blur it to make it kind of blur in better. But I don't know. I feel it's cheating to do it this way. It makes it look nice and clean. It really does. Like the background gets smoothed out quite a bit. But my computer has just like given up on me. There we go. I think it's because I've got like OBS running and everything running. It just wants to give up. So if I go to crop this, crop to content. Give it a second. It's chugging along. So we've got 50-50 split on whether one or two looks better. I don't know. Is this cheating? Like, let's go back and see what the difference would be. Um, it's hard. This is the before image without the clean background. You can do a lot with layers. Like you can hide a lot of things with layers, with different layers. I mean, it looks nice like that, I think. If we're looking for like a nicer image, I think the background is right. If we're looking for like a true, like, be faithful to your data, maybe we shouldn't do that. It's personal preference, I think. I really like I said before, I just like the bar, seeing that bar in the middle. And from what I've heard about the bars, like, yeah, I like the result whether it's cheating or not. Yeah, me too. Me too. Especially it just smooths things out so much. And you can only really do this like with galaxy images, right? Where you can kind of mask out certain portions of the of the image where the galaxy is. But it kind of makes it nice and pleasing, I think. I don't know about the color though. I think oops. I feel like the color on this one is better. Like it looks more natural to me, whatever natural means. Like I don't know what natural means in terms of astrophotography color, but like in my personal preference, it looks more natural than this one. Maybe but then again, I like the way that galaxy kind of looks in this one too. So I don't know. I don't know. Galaxies are fun. Just they're fun things to image. So we're seeing the second one. Should I change the color? So should I try and go here and where is it? Components and then channel mixer. Hi. Oh, cool. Tasmania. Yeah, I could always get a lot of people from the Southern Hemisphere, like Australia, New Zealand, Tasmania. I feel like I stream at that, at the sweet point for that. That's pretty cool. So we got people from all around. Was it Gonzalo from Argentina? And then Tasmania. That's pretty cool. At the exact right time. Yep. Yep. Okay, so let's see. Should we change the color of the galaxy? I guess that's the big question. Do we change the color? I don't know. If we wanted to change the color, I think we would decrease the red a little bit. I don't know. Let's see. Or maybe we increase the green. Yeah, that would be too green. Yeah, when you do it like that, then it kind of becomes weird. I mean, the color looks fine as it is now, but let me see if I can find Hubble image or some sort of image of M58. Maybe from a very large telescope or something. Let's see. Or can the very large telescope even see that? Let's see. See how they processed it. I always like seeing things. So like the closer the first, it might be good to combine them. Yep. Yep. So here's M58 from Hubble. It's fairly white in terms of the core. So I think the color of this one kind of matches it better. Let's see if we can, maybe we can match it better a little bit with a color mixer. Actually, what we could do, I'm going to take this and I'm going to use the picker, the color picker, and I'm going to sample it. See what the colors are. So a little bit more red, a little less green, and the green and blue are a little bit the same. And then we can go here, do the same thing, and just sample kind of the same. So we've got a little bit more red, too much green, not enough blue. So we might want to increase the blue, right? So we can the channel mixer again, increase the blue and the green a little bit. That makes sense. Looks reddish. So increase the blue and the green. Okay, so increase the green and the green channel just a tad, and the blue and the blue channel just a tad. Let's see what happens. Might take a while. Again, my computer's just wanting to be slow. Oh, there. We're getting it. Yeah, I think that's right. I think that's good. Everything's going to be a little bit more blue. And I'm okay with like the sky being a little bit more blue. I mean, but yeah. Hobart, Tasmania. That's pretty cool. What do you think about that? The color's better now? Does it? Yeah. I don't know. I still like the first one. I think this is better, but I still like the first one. Oh, not cool, chilly, cold. Yeah. Is it cold there now? It's. Let's see. I'm gonna check it out. I'm gonna see how cold it is. Oh yeah. Yes. What is it? 9 degrees today, Celsius. Yeah, that's pretty cold. It's cold for me anyway. So I'm in Florida right now, Northern Hemisphere. It's hot. It's like, I don't know. Humid. Humid is the word. Yeah. Feels like 4 because the humidity. I can see that. Three degrees Celsius, south of Argentina. Yeah. I'm so jealous of all the people with the southern hemisphere targets. This must be great. But yeah, I can see how right now it's chilly. Okay, let's see. So we have, do we need a little bit more green? Is that the question? Do we need some more green? We might. This up, nope. Just slowly playing with these colors and the color channels to see if I can get a natural-ish looking color. Can move the red down a tad. Of course, the background's going to be all blue now. Maybe we can use the curves adjustment to change. Yeah, my computer is always slow when it has to stream, process images all at the same time. Okay. Check this, I'm sure it's too blue. It was snowing late last week, clear skies, but everyone had their wood heaters going. So it was smoky. Just can't win with this hobby. Yeah. Yeah. At least I guess smoke isn't quite as bad as clouds, right? Like you can still kind of like image through them. But yeah, it's always better without the smoke, I agree. So you like it now more blue? Yeah, I kind of like it too. Let's see here. Yeah, makes everything look a little blurry. Yeah. A few years back, we were in Maryland, and we were getting smoke from the West Coast, you know, from Canada, and it was bad too. I can't imagine how it would have been up in where the fires actually were, but like we were very far away from the fires, and we're still getting the smoke, and it was you could still image through it, but it was not. We weren't getting very good images. You like the blue? Yeah, it's a little bit on the bluer side. Yeah, I kind of like it too. Okay, so let me go ahead and I'm going to do a new from visible. And because I don't want this to take forever for everybody, I'm going to create a new file, but it's going to be smaller, so it'll go through AutoSharp faster. So curves for the background, yes, that's a good idea. Yes, I agree. Before I do that, yes. So colors, curves, and then go to the blue channel, create an anchor point, a couple of anchor points, and then try to bring this down a bit. How is that? Does that look better? I think it looks better as it's slowly processing things. I might want to bring this one down just a tad too, closer to the galaxy, so it's not quite such a sharp, what do you want to call it? Like a transition between the galaxy and the background. Make small adjustments. You can use an arrow. It took me forever to realize that you can use the arrows too on the anchor points. So if I click it and then press the down arrow, then I can just do that. I think that looks good. I think it blends in okay. Like, I don't know how many years I did, and I still forget it. Like, I don't know. I started astrophotography around 2016, and I've used Gimp since then. Like, I just kind of got used to it. And I always do curves adjustments, and I like the mouse is just, you just have to be so careful. But like the arrows are so much nicer to use sometimes when you want to make those fine adjustments. Okay. Let's go ahead and I'm gonna create a smaller version of this, and we can run it through AstroSharp. And then we can see how to sharpen it. Yes, it looks better. We have to wait a few seconds for the YouTube compression to see the result. Yeah. Yeah, that makes sense. And you have to wait a few seconds for my computer to actually process it. So I'm sorry about that. Let's see. I'll go ahead and anchor this layer and then crop it to the content. There we go. I'll save it as a TIFF file. I think that's a nice, I like it. I like that image. Like maybe I cheated with the background, but I don't know. It's pleasing. It's a pleasing image. Okay, let me export this real quick as a TIFF. And then I'll start AstroSharp. And we'll see. We'll see how it goes. We try sharpening it first. I don't think it needs too much sharpening. Like everything looks pretty nice. I looked at the full width half maximum in Serial, and the stars are pretty kind of like big. They're like the full width half maximum is pretty big, but like it's nothing that's too crazy. Okay. Loading it in now, and then we'll see. I have someone really generous, like a software, not a designer, but like someone who figures out like how to make software look good. And he gave me some ideas to how to make the UI look nicer. And so I want to try and implement that too. I just haven't had the time. This is really weird. Why is it so white? I don't know why it's so white. Like the background, it looks very bright. Okay, so I've got some stars, got a good sample of stars, and I'm going to use the dual PSF model with be fairly aggressive on the background and not quite as aggressive on the stars, and we'll see how it goes. Some say cheatings, other will say changing the style. Yes, that's right. Okay, so let's try the dual PSF on just this sample. Okay, so it's going. We'll see how the stars look compared to the background. Yeah, maybe the stars need a little bit less sharpening. We'll see. Yeah, I really want to make AstroSharp like a true deconvolution tool. I mean, I feel like it kind of is. Like the way the neural network is treating things, it is doing some sort of deconvolution, but you just never know. And I've got ideas to actually sort of make it a deconvolution tool, and I'll probably explain this all, in the next video that I'm doing, or maybe not the next video, but the video after that about, deconvolution things. I think that's good. I think that's fine. I don't know if the background is sharpened too much. Bring that down a little bit too. And I'll just use the single core right now so I don't mess up the YouTube stream with taking, bottlenecking my system with my CPU. Okay, so I'm going to do the full image now, and we'll wait, see. I think it'll take probably 3 or 4 minutes for it to process. I know AstroSharp is slow, I'm sorry. There are ways that I would change it now to make it faster, even with this. But I just need more. I need time. I don't have a lot of time at the moment. I'm sort of interested in what you all are using to process your images. Do you use PixInsight, free software, Photoshop, Gimp, Zero? It's kind of it's just interesting to see what people use, what they like to use. I kind of got stuck on Gimp because I was, just a grad student. Not a lot of, I spent all my money on the equipment. And so I figured I could save some money with Gimp. And Gimp at the time, right before I started astrophotography, or maybe during, it couldn't process 16-bit images. And then so I thought I was out of luck and I would have to buy something like Photoshop, but a month after I started, the new version of Gimp came out and it could process 32-bit images, which was, kind of what you need. You need something, right? 8-bit's just not going to cut it with astrophotos. So Zero Photoshop your software. Cool. Very cool. Yeah, that's pretty much my workflow, except exchange that with Gimp. But has this frozen? This slider hasn't moved anywhere in the past couple minutes. Hope not. I hope it hasn't frozen. Check the console. It says it's running. Check my task manager. It should not be taking this long. But then again, I don't know. My system seems to be running very slowly right now. So not exactly sure. Got too many programs open. That's what's going on. Got YouTube with Chrome, everything. Taking a while. OBS. I like how it looks with AstroSharp. I'm going to try it. I don't have much experience with that kind of process. I tried to do deconvolution with Zero, but I hardly noticed a difference. I don't know if I did it wrong or if it is just like that. Sometimes deconvolution is, you don't notice too much of a difference, especially if your stars are really sharp to begin with. You might not notice. Plus, if you do have some noise in your image, that can always throw off things. It doesn't even have to be just noise is just bad for deconvolution, any noise. And so that can be bad, but Let's see here. It says error, YouTube is not receiving enough video to maintain smooth streaming. As such, viewers will experience buffering. Sorry about that. Let me see if I can close some things to make it easier on the system here. Don't need Cyrillic anymore. Let's see. Just closing all programs that I don't need. We'll see. Let me check OBS real quick. So it's sending enough information, I think, for now. But I might be dropping some frames. But yeah, I would say with deconvolution, it's very easy to not notice the difference if your stars are very sharp. I think a lot of people sometimes, especially in the early days of Blur Exterminator, they would find the same thing. That like Blur Exterminator would like make their stars a little bit sharper, but it wouldn't. They didn't notice like a huge improvement. And you know, the way that Russell Croman has set it up, I think he's trying to make it to deconvolution, and it can really help when your stars are very, you know, like when things are kind of out of focus. It can really help tighten everything up and make those stars look really good. But at the same time, if your stars are already in focus and your tracking is good and you just have good data, sometimes deconvolution doesn't give as much of a benefit as you might think. But yeah, I noticed that with AstroSharp. Like I have this image of the Lagoon Nebula that I took with, I think, like a Starlight Express CCD camera that was very, you know, had a very small sensor. And at the time I was just starting to get into like autofocus. And I had I don't know, it was like one of the cheaper autofocus things that didn't have, what do you call it? It's like it couldn't tell what position it was at. And so it was hard to get it in focus, and it would slip all the time. Part of the reason it would slip was because I didn't have the focuser tightened down quite enough. And I didn't know that when I was actually doing it, but it would just slip. And I had quite a bit of data of the Lagoon Nebula from a night of imaging, and the stars are big. they were kind of like, it was not quite in focus, and it just wasn't doing a good job at, you know, focusing, because the thing was just a cheap, you know, just a cheap thing. And so but I put it through AstroSharp, and the stars went from like this, I don't know if you can like this, you know, they really tightened up. And I think if I had done just regular deconvolution in Serial, it would have kind of maybe done a similar thing. So yeah, so maybe your data are too good, right? So maybe that's your problem. You just had such good data, such sharp stars, that deconvolution just wasn't, you know, didn't help that much. So. Okay, let's see. Yep. Okay, I'm just closing all the programs that I don't need. Things I think are running a little bit faster now. Oops. So yeah. Oh, here we go. It's finished. So I'm going to go and download this and we'll take a look at it in Gimp. And we'll see if we can spot the difference between the before and the after. Okay, so here is the after. This is before, after, before, after. So the stars, I think you can see they're sharper. I think that there's more structure in the galaxy. I feel like something happened here, which I'm not too pleased about. Sometimes when things are kind of bright, AstroSharp does some funky things. So I've had problems with that, but I can just mask that out. That's I think fairly simple. The stars are a little bit sharper as well. So before, after, it's an okay job, I think. Okay, I'm going to try it with more out of focus photos. I have many of those. Yes, you should try it. Try it and see what happens. I think everybody has a lot of out of focus photos. I certainly do, at least, especially before I got, I have a ZWO focuser now, which is a lot better. So I'm going to go ahead and add a layer mask to this. And well, let me wait on that. What I want to do is browse. Oh wait, let's see. Before I do anything, let me turn it back to preview so it's not doing the whole image. And I'm going to go ahead and browse and find that sharpened image I just had. And we're going to run through AstroClean and see if AstroClean helps clean it up. Then we can mask off some of the areas that are kind of weird. So let's go ahead and do AstroClean, update the sliders. And then we can just go into a full image and, I don't know, take another 10 minutes, who knows. Doing it faster this time, I feel like, since I've closed all those other unnecessary programs. Like I had Discord running and Slack running and some other things running. I just closed it all and it's fine. It's better. Are you guys getting a lot of drop frames or buffering? Hey, good evening, Pete. How are you? We've been processing some M58. This is a cropped image of it. This is before I put it into AstroSharp and after. We're just checking out the stars. They've kind of shrunk a little bit, which is nice. So this is the first iteration that I did. then this is the second, well, not this one. This one's the second one I did. And then we just took this and cropped it, put it here, ran it through Astro Sharp, and we're running it through Astro Clean. So yeah. Oh, let's check it. Let's see. Yeah, it's running much faster. Not so much now. So there was some buffering before. I think that was because I had so many programs open and my processor was about to like explode. So it wasn't able to send enough data to YouTube. But it's telling me I have a good connection now. But before, I guess it wasn't. Could also be my internet. Sometimes my internet is slow. Oh, thank you. Thank you, Pete. Let's see. I think I like it. I did a lot of cheating to make it look nice, like to make this background nice and smooth. I added in another layer of an unstretched, of the unstretched TIFF or FITS file, so it wouldn't be quite as noisy. A little secret I used. It's probably cheating, but I think it makes the background look more pleasing. The same thing with this one. And then, yeah. So let's see here. Yeah, okay, we're done with this. So let's go ahead and download it and we'll see how it turns out. We just put it through Astro Clean, which sounds like a cleaning product, I feel like. Maybe we call it Deep Sky Denoiser. I don't know. Maybe that would be a better name. I didn't put enough thought into what I should name things. I think probably Dylan O'Donnell did a video shortly after Astro Sharp came out about how people name things in astrophotography. Just put an astro in front of everything. Yeah, cheating with backgrounds. Yes. Yep. I think it's fine to cheat as long as as long as you're not like manipulating it, unfairly, to make it look like there's more detail than it is. But I think like trying to smooth out the background is fair game. Okay, let's see. Open his layers. You find the noise one, and we can compare it like just things. Okay, so this is the sharpened one. This is the original. I feel like the sharpened one did some weird things. So like you can see this line here. I don't know why that's there. It's weird. So, and then the denoising. I don't like. It's definitely less noisy here with Astro Clean, but again, something like weird happened here. I don't know if that's the way. That could have been just me. Huh. There's like squares here. I've never seen this before with Astro Clean. Like I get it. Like it's the. That's strange. Biostar Deep Clean now with less noise. Yeah. Biostar Deep Clean. Yeah. So I don't know. I don't know if I'll keep the. Let's see what happened here. Yeah, so something happened here where it cut off at this section, like it's treating this section a little bit different than the other sections, and so that kind of got amplified, I think, a little bit. So got some artifacts. We got this weird square going here. I don't know if you can see it in YouTube. I zoom in. There's a square right here that's a little bit lighter than everything else. So not sure exactly what's going on. So maybe I won't use Astro Sharpen Astro Clean on this. Maybe I have to go back to the drawing board and do some things. Fix some things in the program. Let's see if we can find any other weird artifacts. Kind of gets rid of the diffraction spikes in some of those medium stars. Hi from Chile. Nice. Hi. So I don't know. What do you think? What do you all think? Does it look okay? Definitely APOD material, right? Like, sure. Like, we should submit this to you. Just kidding. I think it looks. I think it looks decent. I think like before we put in Astro Sharp and Astro Clean, I think it looks really not bad. We've got some good structure in the spiral. You can see the arms. You know, you can see these arms here. You can see the bar. The background has been. I've cheated with the background. Like, that's just the way I do it. And the stars look okay. I mean, maybe I should work on my collimation a little bit, or maybe I've got some pinch optics or something, making the stars look a little bit weird. I'll probably be putting up my RC for a few months anyway, and breaking out my refractor because the Milky Way is coming back. So we can maybe compare the two. This is the first one again. The second. I think I like the fuzziness of the galaxy in the second one, and maybe the colors of the first one still. But I think they're both fine. I like them. I'll probably end up at some point doing a third iteration. Always feel like you can never do enough reprocessing of your old data. But I've always liked Messier 58. I just think it's a nice barred spiral galaxy. But like if you're zoomed out too much and your resolution isn't good enough, it can be a hard target, which is why I used the RC on it. Maybe I should have used my C8, but that would have been kind of difficult with my mount to get longer exposures. I could have done like 15-second exposure with my C8, but it would have taken a long time to get some good data. Although with the RC, it's probably about the same in terms of the signal to noise ratio, maybe even a little bit worse. I have the GSO. So I got the GSO RC probably back in 2020, right before the pandemic hit. And like I ordered it in November 2019. I got it in like March. So I was kind of looks good. I like it. Thank you. Thank you. I like it too. I generally like the RC, but like I was at the beginning of the stream, I was telling everybody that it doesn't do very well with broadband in terms of getting rid of the flats because there's light that can enter in through the side that just goes directly from. So if you think of, I don't know. So if this is the telescope opening, like of the RC, and like this is the back where the primary mirror is. Light can get in through here. That's like just light pollution, like from a street lamp or whatever, and it just goes in directly into the sensor. And there are some 3D parts that you can print out to help mitigate that, and I've done that, and it still does it. So I can show you maybe. Well, I can't show you. I cloned out all the dust motes, and I have to clean my luminance filter, I think, because it's got a lot of dust on it. But yeah, that GSO, there's a lot of little quirks with it that, like, if I had known about those quirks, maybe I would have tried something else. So yeah, 39 degrees altitude from here. Not bad to try to, yeah, that's cool. Here it's pretty high for us. So I think, let me just open up Stellarium and see. Right now it's, I mean, back in May, it was probably perfect to image, which is when I start imaging it. Like, it's just good. The problem is I set my telescope up kind of next to my house, and the roof gets in the way. Let's see if M58 still might have. Yeah, it's pretty low now, but back, a couple months ago, March, April, it was perfect. Let's see. So maybe we can change the date. So if we go back in time to like March, then where are we? Yeah, like 71 degrees up, like in the zenith, maybe even like better than that. So yeah, it was pretty good. It's pretty good. Let's see. So Pete says, I'm normally into wide field refractors, but bought a 12-inch GSO RC for doing galaxy work. Oh, that's pretty cool. Yeah, that would be nice. I think the 6-inch, I think the 12-inch is good. Like maybe the 8-inch, 10-inch, 12-inch, they're like those RCs are a lot better than the 6-inch, because the 6-inch, the mirror is so small relative to the secondary that you lose a lot of contrast, and so it's a slow scope to begin with at like f10, but like the mirror blocking such a percentage of the secondary mirror blocking such a big percentage of the primary, like it makes it even slower. And then there are like a lot of little quirks with it, like the flats just don't work with broadband, and the focuser isn't like great. Like it, there's creates some tilt based on where it is in the sky. And like if you want to make that scope good, you have to buy, another focuser for it, and you have to buy like, I don't know, different things for it. And you really should get some sort of coma corrector for a Ritchie creation, which all these little things sort of add up to make a scope that used to be $400, which is like back in 2020, that's like what it costs. Now it's probably like $500 or $600 for the 6-inch. But like a scope that like seems like a good deal at first, you just keep adding on more and more accessories, and it becomes no longer a great deal. And that's just sort of my opinion. So yeah, but back a couple months ago, like, I'm sorry I'm going on different tangents, but like I was very excited to use the RC on this target because it felt like a good focal length to do it. This is paired with my camera. I was thinking of getting my old C8 out and imaging it with a C8, but the focal length is way too long, you know, for that. Also the 10-inch and 12-inch truss tube RCs have the focus tilt ring built in. Yeah, that's nice. Yeah. Plus it's like a truss tube, right? So you can get into it more. Like the 6-inch has the tube, you know, it just has the everything all around it, and so you can't, like, again, like, you need a 3D printed part to stick in there to help mitigate that light going in from different directions, and it just really, like, you can't even stick your hand into it, you know, without messing things up. But focuser is garbage. I upgraded mine with TS Optics 3-inch focuser and 0.8 reducer flattener. Cool. Yeah, I feel that's what needs to happen. Maybe, okay, so maybe I misspoke, right? Like with an RC, you don't need a coma corrector, but you need like a field flattener because there's still curvature or whatever. Like it always confuses me, like with RCs, like what does it correct for and what doesn't it, you know? So I think, yeah. So like, does it correct for coma and not field curvature, or does it correct for field curvature, not coma? I can't remember. I can never remember. But on paper, it, you know, the 6-inch seems like a good deal, but I would probably, if I had to redo it, I would have got maybe the 8-inch or just something else, like maybe a fast Newtonian or something. So I think that's about it for me tonight. This is the final image, and I bet what happened, I think I know what happened, is like this background is not the real background, so AstroSharp wasn't trained on such a smooth background. Like, so I think there's some artifacts because of that. But I mean, I think it's okay. So, whew. Yeah, I've got another pair of galaxies, an antennae galaxy that are right next to it that I've got a few hours of data onto that I need to process, but I just haven't got around to it. So, where are those things? Yeah, the Siamese twins. I got these two. So while I was doing M58, I was also imaging these for a couple of nights. I don't have nearly as much data, but I just thought this was just such a cool target. I really like the interacting galaxies, like the ones that are merging. They're so cool. I think I can maybe like open up, show you all what one of those just subframes looks like, because it's not like the best. C40. Yeah, here it is. Like, just to show you kind of what the RC does for a 1/22 sub with a ZWO 294mm camera. So let's see. You need to get yourself around to it. Yeah. Let's see. This is one subframe of those around to it. Yeah. That's right. I do. I need to get myself around to it. That's right. I didn't get it at first. I was too focused. Yeah, so this is what one subframe. I mean, it's not bad. You can see this. You can see a lot of the interactions. There's another galaxy here, which is cool. Another galaxy there, which is cool. Just cool stuff. But yeah, that's what one subframe looks like. I mean, like, it's not bad. for galaxies, because galaxies are so concentrated anyway. But same time, there's always a little bit of stuff with that 6-inch that I wish was just a little bit different. So, yes, I could hear the gears crack. Yeah, I was like, a round to it? What is a round to it? And then I put it in my head and I got it. So, but yeah. All right. Well, I think I'm going to end the stream there. And I just want to thank everybody for keeping me company as I process this stuff, because it's always more fun, I think, when you have people to talk to as you're processing it. You can ask them questions and stuff. Yeah. Thank you. So thanks everybody for coming out and taking time just to chill with me for a little bit. I know not what I usually do in terms of like videos, but yeah, thank you. Yeah. See you next time, and I'll probably end up streaming again and processing the Siamese twins. Maybe even doing like a first round processing to see how it goes. Yeah, it was fun. Thank you. Thanks for joining me. Great stuff. Just noticed your stream as I was shutting down. Yeah. Yeah, hope to catch you again too. Hopefully, yeah, I'll probably maybe stream next week, or I don't know. I'll let you know. I'll probably not do it so impromptu next time. So I'll let people know beforehand, like that I'm planning to stream either like 1 or 2 days ahead of time. But I'm off tomorrow from work, and I thought, well, it'll be a good time to do it, because then I don't have to worry about waking up early and things like that. So, yeah. Thanks everyone. I hope everyone has a great week, and hope whatever you're imaging, you have clear skies and everything. So, and hope to catch you again next time. Bye.